Our story begins in the 1820s, Germany, with George Ohm.
Ja, welcome to Deutschland.
Ohm entered the University of Hagan and received a doctorate.
Hurrah!
Ohm began experimental work in a school physics laboratory after he had learned about the discovery of electromagnetism in 1820. Scientific philosophy in Germany at the time said that experiments did not have to be performed to develop an understanding of nature, because nature is so well ordered. So this kind of experimenting was controversial.
You despicable human being. Dummkopf. This isn't how science works.
Dummkopf?
Yeah.
Das ist nicht so gut.
Yeah, it's wrong.
Why?
It's all wrong.
Why?
All wrong.
You wait. You will rue this day. I will prove you all wrong.
And George Ohm did prove his haters wrong. Science rules! Using the results of his experiment, George was able to define the fundamental relationship between voltage, current, and resistance. What is now known as Ohm's law appeared in his most famous book, a book published in 1827 that gave him his complete theory of electricity. What is now known as Ohm's law appeared in his most famous work, a book published in 1827 that gave his complete theory of electricity.
Oh, look at me. I'm a published author now. Go buy my book on Amazon.
The equation I equals V over R is known as Ohm's law. It states that the amount of steady current through a material is directly proportional to the voltage across the material, divided by the electrical resistance of the material. If you break that down, voltage is the difference in electrical potential. It is measured in volts. Current is the rate at which electrons flow through a given point. This is measured in amperes. Resistance measures objects. Voltage is the difference in electrical potential. It is measured in volts. Current is the rate at which electrons flow through a given point. This is measured in amperes. Resistance measures an object's opposition to the flow of electricity. This relationship was the birth of electrical current or circuit analysis. This relationship was the birth of the electrical circuit analysis.
Oh, that's tingles.
A helpful tool to remember this equation is this triangle. To find V, you cover up the V, the top of the triangle, and you have I times R, and that will give you V. And so to find I, you cover it up, and V is over R. So that's how you find I. And then to find R, V is over I. And so that's a helpful tool, just in case you forget the equation.
Let's do a simple problem to prove that this is true.
Really bad.
A given EMF source of 6 volts is connected to a resistor and a current of 2 ammeters.
Don't make me cook
Close
you again,
to it.
Mr. Walter.
All the wires are resistance free. What is the total resistance? So first we drew our picture. The gain of potential energy occurs as the charge passes through the battery, and that is, it gains the potential of volts equals 6 volts. No energy is lost in the wires because they assume that it will be resistance free. By the conservation of energy, the potential that was gained must be lost in the resistor. So, by Ohm's law,
Hey, Mr. Walter.
so, or R is what we need to find, so that becomes 6 over 2, which equals 3 ohms. Yay, physics!